Answer each of the following questions related to the unit circle. In Part A, what is meant when you are asked to find p at pi over 3 on the unit circle? P at pi over 3 means when the terminal arm is at an angle of pi over 3, the terminal arm intersects the unit circle at the point labeled P. Find the point P at pi over 3 on the unit circle. P at pi over 3 simply means point coordinates at pi over 3. In Part B, find one positive and one negative angle such that P at theta equals root 3 over 2, negative 1/2. Find the angle with the given coordinates on the unit circle. The coordinates at 11 pi over 6 are a match. The positive angle is 11 pi over 6. The negative angle is negative pi over 6. Now we'll move on to Part C. How does a half rotation around the unit circle change the coordinates? If theta equals pi over 6, find the coordinates of the point halfway around the unit circle. Find the coordinates at pi over 6. They are found on the unit circle. Now find the angle halfway around the unit circle. We can calculate this by adding pi to our current angle. Pi over 6 plus pi equals 7 pi over 6. Now find the coordinates at 7 pi over 6. They can be found on the unit circle. We can generalize that for a half rotation around the unit circle, the numerical values of the x and y coordinates remain the same, but they each take on the sign of the new quadrant. Now we'll move on to Part D. How does a quarter rotation around the unit circle change the coordinates? If theta equals 2 pi over 3, find the coordinates of the point a quarter revolution clockwise around the unit circle. Find the coordinates at 2 pi over 3. They can be found on the unit circle. Now find the angle a quarter revolution clockwise around the unit circle. We can calculate this by subtracting pi over 2 from our current angle. Two pi over 3 minus pi over 2 equals pi over 6. Now find the coordinates at pi over 6. They can be found on the unit circle. We can generalize that for a quarter rotation around the unit circle, the numerical values of the x and y coordinates swap, and each new coordinate acquires a sign of its current quadrant. Now we'll move on to Part E. What are the coordinates of p at 3? Express coordinates to 4 decimal places. We can find p at 3 on the unit circle by converting 3 radians to degrees. This gives us 171.8873 degrees. Note that we will not need the degree value for this question beyond quickly finding the location of the terminal arm. P at 3 means Find the coordinates when the terminal arm is at 3 radians. On the unit circle, the x-coordinate is the cosine value and the y-coordinate is the sine value. Therefore, p at theta equals cos theta sine theta. Use a calculator to get cos 3 equals negative 0.9900 and sine 3 equals 0.1411. Make sure the calculator is in radian mode since the angle is a radian. The answer is p at 3 equals negative 0.9900, 0.1411.